All right, the theater sells 3 types of tickets: general admission, senior, and child. So are you good with our variables being general admission for G or for the general admission, S for senior, and C for child? Okay. Now, be careful with the S's, because I do this to myself sometimes, but yeah, some people's S's and 5s look identical, and then you get confused, and then bad things happen. Kind of like with the Q and the 9 the other day, right? And so you just got to be careful with that. If you're like, I'm going to mess that up, make it something else, it's fine. But if you can make it make sense with the question, I always think that's a little easier. All right, so Mark bought 9 general admission, 2 senior citizens. So let's see, this is Mark's. This is what Mark did. He bought 9 general admission, right, plus 2 senior citizen tickets and 3 child tickets. And he paid $170. Okay? So my variables, do they represent money or the number of tickets? Number of tickets, that's what my variables represent? No. The price. The 9, the 2, and the 3 is how many they bought, or how many Mark bought, right? So that if I had 9 general admission, 2 senior, and 3 child, the variables here represent the cost of each different ticket. You with me on that? And so that means that when I multiply them together, I get money plus money plus money equals money, and that's good. That's what I want, right? Okay, so then let's keep reading here. All right, so then we're going to talk about Sarah. What did Sarah do? Sarah bought 5 general admission plus 4 senior citizen plus 7 child tickets, and she paid $173. Yes? All right, and then Kyle bought 4 general admission, 1 senior citizen, so I can really just put S and not 1S, but you could do either way, plus 6 child equals $116.50. Then it says, find the cost of each type of ticket. This is also what can help you with that if you're not sure if what your variables even represent. Well, this is what you're looking for, so that's what it has to represent. You with me on that? Whoop. Any questions at all at this point? Does it matter? Does the M, the S, and the K, and who did what, does any of that matter? It doesn't. I labeled it because, sometimes it matters, like, what was the cost of, how much did Sarah pay for her general admission tickets or whatever. But this right here doesn't really matter. So sometimes we label things and they're like, I don't need it. Maybe I'm going to mark it out so I don't mess things up. Now, after yesterday, when we did that, and it's fine if the answer is yes, do you feel like I need to actually do the work to solve these, or do we understand that process from yesterday? Are we good on that? Like how we eliminated and went through it? Okay. I think we are. I just wanted to talk through the word problems again. Okay, so then, and you're going to do another one at the board. I'll come help you if you need to. Let's flip it over, and next I want to do number 9. Okay. And actually, let's just read this. I'm going to give you a second to try and write the equations, and then we'll do it together. You can, if you want to do it on the table, that's less threatening, knock yourself out. Okay? Yeah. If you don't want to write it on your paper yet, I'm okay with that. So read over it, see if you can get some equations written. I'm actually taking this hat off because it's making me sweaty. Extra sweaty. Amazon. It's okay, write something. Okay, I'm going to use G, S, and B. Are we okay with that? Got to make sure your G doesn't look like a 9, your S doesn't look like a 5, and your B doesn't look like a 6. And if it does, maybe you use X, Y, and Z. But make sure if you use X, Y, and Z, you know what X goes with, what Y goes with, what Z goes with. Otherwise, none of it even matters. Okay? So let's read this question. And the other day, didn't one of y'all go like, oh, look, I'm Miss Finnan, or one of y'all were making fun of me at that table. Was it you? Maybe it was during math time, somebody over there. And somebody did this and said something about being Mrs. Finnan, and I was like, I don't do that, do I? And then I caught myself yesterday doing this, and I was like, I guess, and I just caught myself again. I guess I do that. I didn't even realize. 3 medals earned in the Olympics are gold, silver, and bronze. In the 2014 Winter Olympics, the United States had 28 total medal winners. There were 2 more gold medals than silver medals, and the number of bronze medals was 4 less than the sum of the number of gold and silver medals. How many winners were there of each type of medal? Now, I know when you read through that at first, you're like, wow, that's a lot of information. Nobody expects you to read it and be like, oh, here are my equations. But one good reason to read through it first, on that first one, I didn't model that very well. I just started writing stuff from the beginning. But because when I get to here, how many winners were there in each type of medal? That's telling me what my variables are actually representing. How many gold, how many silver, how many bronze. So if I start back here, the United States had 28 total medal winners. That means I take all the gold medals plus all the silver medals plus all the bronze medals, and what does that have to equal? 28. Okay? That's how I know I can just add the 3 up and get 28. Because it's number of medals plus number of medals plus number of medals equals number of medals. So you can kind of think about it that way to make sure that, you know, your labels are matching up. Okay, so then this next part of the sentence, it is complicated for some people, and I'll tell you how I think through it. It says there were 2 more gold medals than silver medals. So there, it doesn't say gold is 2 more, you know, it doesn't say it like that. So when you hear a question like that, it's either gold equals silver plus 2 or silver equals gold plus 2. So hopefully from that statement, there were 2 more gold medals than silver medals. Which was there more of, gold or silver? Gold, right? So that means my gold has to equal silver plus 2. That's how you can make sure you're adding it to the correct side. You with me on that? Because that can get confusing. Because remember, English is the backwards language, so sometimes logically and mathematically it doesn't sound the right way. But after you read it, say, okay, gold, there are 2 more gold than silver. That doesn't mean I add 2 to gold, and that's a mistake I see a lot. Okay, so you just kind of ask yourself, which one is more? Gold is more, so here's my silver. I add 2 more, that gives me my gold. Okay, we good on that? Then it says the number of bronze medals was, which is a different form of is, right? So number of bronze medals was or is 4 less. So it's not 4 minus, right? 4 less means I'm subtracting 4 at the end because of then. Oops, and I probably need to move it over more. 4 less, I'll move it over here. 4 less than the sum. What does sum mean that I do? What operation? Add. The sum of the number of gold and silver medals. So this is going to be gold plus silver. Now, do those parentheses really do anything? No, but it's 4 less than the sum of this. So technically you add these, then you subtract that. And so you want to be careful when you were, because if it said like was 4 times the sum of the gold and the silver, then I would absolutely have to have the parentheses there, right? So it's just a good habit to put it in there like that. And then you can go, you know what? They're not really doing anything, and then they can just disappear. Now, looking at this, do you think that this is better? Would you force this into elimination, or does substitution maybe seem like a better option here? To start with, anyway. Substitution. Like, because I already have this solved for G, so I can substitute this guy in here. This is, you know, and then I can just kind of go from there. Or you can make it into elimination if you want to. It doesn't matter either way. Okay? Everybody good with those? Okay, perfect. So here's what we're going to do. We're going to split up the rest.